Welcome to this explainer. Honestly, I am absolutely thrilled to get into this one today because we're talking about a real game changer for developers and creators alike. We're diving into this awesome concept called desktop liberation. Basically, we're going to break down a proven, super clever methodology for mashing up hosted and local large language models. Why? To literally slash those painful API costs right down to the bone, getting you the absolute best of both worlds. Let's get into it.
So it really all boils down to one massive question. If you're an open source dev or, just building some incredibly ambitious software, you obviously want that top-tier, elite AI coding help. But how on earth do you get that high-level, complex code generation without racking up absolutely massive token fees, right? I mean, every single time a powerful cloud model starts spitting out a huge block of code, it's like, cha-ching! You just hear that cash register ringing in your head. It's such a relatable dilemma. We crave the genius of the cloud, but there's no way we want that exorbitant price tag.
Okay, so here's our roadmap for today. First, the token cost dilemma. Then, we'll check out the gas fakes project, unpack the whole hybrid LLM strategy, dig into the delegation mechanism, and wrap up by actually setting up local execution.
Section 1. The token cost dilemma.
Let's be real for a second. Open source work? It's usually voluntary. It's unpaid. So as an open source dev, you're constantly stuck doing this mental math, balancing the potential token costs, which, let's not forget, come straight out of your own pocket, against the value of the time you're saving. Having a hosted model churn out and test massive amounts of routine code, it just costs way too much. The grunt work should absolutely not drain your wallet. The math just completely falls apart when you're talking about generating thousands upon thousands of lines of highly repetitive testing code.
Moving on to Section 2. The gas fakes project.
94. That is a 94 out of 100 enterprise-grade score. We are not just talking about some theoretical fluff here. The source material actually uses a massive real-world project called GasFakes as its ultimate proving ground. Basically, GasFakes is an emulation tool that frees up native Google Apps script code so you can execute it locally. And get this, even before applying this hybrid AI strategy we're going to talk about, a Gemini assessment looked at the GasFakes repository and handed it a 94 out of 100, officially stamping it as a production dev tool.
Just look at these straight A grades across the board. We're talking an A+ for architectural design, an A for testing, another A+ for ecosystem readiness. This isn't just some tiny throwaway script, it's a seriously complex piece of software. And what this proves is that the codebase is incredibly mature. So because the architecture and the core techniques are totally dialed in, the author realized something huge. The rest of the work? It's basically just busy work. It's just implementing and testing the remaining kind of obscure platform methods. And you know what? That is the exact moment you want an AI to swoop in and take over the wheel.
To put the sheer scale of this into perspective, grab a load of these numbers. GasFakes version 2.5.3 has already wrapped up 4,399 out of 6,708 methods. Plus, it has over 10,500 parity tests running against live AppScript. You absolutely, positively cannot just ask a premium paid cloud API to generate and test those remaining thousands of methods. I mean, you'd rack up a bill that would make you dizzy. But since the work is highly repetitive, it is literally the perfect candidate for AI delegation.
All right. Section 3. The hybrid LLM strategy.
So here's what desktop liberation actually means in practice. We're taking the advanced, big-brain planning capabilities of a hosted model, in our case Gemini, and we're smashing it together with a totally free local model that handles all the grunt work. For this specific setup, the source uses Gemma running locally on a Mac. And the beauty of this? By doing it this way, we keep our Gemini API costs insanely low, while all the heavy lifting, the actual file writing, the testing, the tedious stuff, happens right on our local machine for $0.
I actually really love to frame this as a classic manager versus employee dynamic. On one side, we've got our strategic planner, right? That's the hosted Gemini model. Think of it as the high-paid executive. Its whole job is high-level planning, managing the context, and figuring out exactly what needs to get done. On the flip side, we have our focused executor, the local Gemma model. Think of this guy as the intern. It handles the high-fidelity execution and all that resource-heavy grunt work. It figures out how to get it done. So the executive orchestrates the whole shebang, and the intern does the heavy lifting.
Which brings us to Section 4, the delegation mechanism.
Okay, let's look at the actual nuts and bolts of how this works. The hosted planner is equipped with a very specific tool called Query Local Model.
When Gemini looks at a task and realizes, whoa, this requires a ton of repetitive, heavy local computation, it doesn't even try to solve the problem itself. Instead, it neatly structures a call right through that query local model tool. This routes the tasks straight from the high-level planner down to the local executor using an MCP server. You can kind of think of the MCP server as a universal translator for AI tools.
Now, the absolute most crucial point here is, we literally have to forbid the expensive planner from doing the work itself. Seriously, look at this brilliant system prompt. It sets up what's called a zero-tolerance delegation gate. The prompt explicitly, in no uncertain terms, tells the hosted model you are forbidden from using write file to implement logic or write tests. And why? Because if we don't enforce this golden rule, the hosted model is just going to eagerly write all the code itself, and bam, charges for all those tokens. So we're basically forcefully handcuffing it, limiting its capabilities so it has absolutely no choice but to delegate.
This sets up a strict mandatory sequence that the system has to follow. Step 1. The hosted model does its research and gathers all the context. Step 2. It is forced to make a call to oMLX/query local model, passing along very specific constraints. Step 3. It just waits. Then it reviews and synthesizes whatever output the local model hands back. And step 4. Finally, it applies the actual changes. Doing it this way ensures that the totally free local model grinds through all that heavy logic, the testing, the refactoring, all of it, before our expensive Gemini manager steps back into the room to sign off and finalize things.
All right, final stretch, Section 5, setting up local execution.
So the secret sauce, making all of this magic happen locally on a Mac, is a tool called oMLX. It acts as the middleware layer. You can think of it as an MCP server, a model communication protocol. It basically just sits there quietly, listening for any requests trickling down from Gemini, and then properly routing them straight over to your locally running Gem instance.
And it's shockingly simple to hook up. You just need a few configuration keys to point your coding platform right at your local desktop server. You grab the AGIY_custom base URL and set that to your local host port. Then you set AGIY_default model to whichever specific local model you're running, like Gemma 4E4B IT OpticQ 4-bit. And lastly, you just pass in your local API key. Bam! With just those simple environment variables, your fancy cloud-based executive knows exactly where to find its hardworking local intern.
Finally, we got to make sure the whole thing is actually working, right? Here are the quick diagnostic steps to verify your setup. First, just hop into your command line interface and ask it, hey, are you able to use the local model? Second, keep an eye on your server logs. You're hunting for a message that says oMLX/query local model. That confirms the delegation tool actually fired off. And third, glance over at your oMLX dashboard. You should see a little generating status right next to your local model. If you see that, boom, you have successfully connected your high-paid manager to your totally free local employee.
Well, there you have it. We've dug into the massive token savings, those super strict delegation rules, and the exact local setup you need to pull this off. I really believe this hybrid workflow completely changes the economics of open source development. So I'm going to leave you with this one thought. Now that you actually know how to build a completely free AI coding agency right on your own desktop, what ambitious project will you liberate next?